Okay, in this video, we will solve this first order differential equation. We have y dx plus parentheses 2xy minus e raised to negative 2y dy. And we will solve this question using the exact equation method. And so the term that is dx, we say that p would equal y, and q would equal the term connected with dy. So q would be 2xy minus e raised to negative 2y. Now we take the partial derivative of p in terms of y. So this would be 1. And now we take the partial derivative of q in terms of x. So this would be 2y. And since we're taking the partial derivative in terms of x, this is treated as a constant. So we would get 2y. Since py does not equal qx, therefore it's not exact, and we have to use an integrating factor in order to make it exact. And so the two integrating factor that we can use is e raised to the integral py minus qx divided by q, or e raised to the integral qx minus py divided by p in terms of dy. And the method that we typically choose, we look at what's being divided by p divided by q. Q is pretty complicated, but p is pretty simple. This is what we generally use. So we'll use this method. And so qx is 2y minus py. Py is 1, minus 1, divided by p, divided by y. And this would become 2y divided by y is 2, minus 1 divided by y is minus 1 over y. We take the integral of this, and we would get 2y minus ln y. So this is equivalent to e raised to 2y times e raised to negative ln y, which is in turn equal to e raised to 2y divided by y. This is our integrating factor. And so we multiply this by all of this. So we would get e raised to 2y divided by y times parentheses y dx plus parentheses 2xy minus e raised to negative 2y dy is equal to 0. And so we would get e raised to 2y dx plus parentheses 2x e raised to 2y minus, this would cancel this term out, so we would get minus 1 over y dy. So now this is still our p term, and this is our q term. So we say p is equal to e raised to 2y, and q is equal to 2x e raised to 2y minus 1 over y. And now we take the partial derivative of p in terms of y, and partial derivative of q in terms of y. Partial derivative of p in terms of y would be 2 e raised to 2y, and partial derivative of q in terms of x would be 2 e raised to 2y. Since they are now equal, it's going to be exact. If in the event for some reason they weren't equal, you probably made a mistake and you should go back and check your integrating factor. So now we can just say p is e raised to 2y, and our q is 2x e raised to 2y minus 1 over y. And now we take the integral of p in terms of x, so integral of e raised to 2y dx, and we take the integral of q in terms of y, so the integral of 2x e raised to 2y minus 1 over y dy. So the integral of this in terms of x would be x times e raised to 2y, and the integral of this, so integral of this part right here would be x times e raised to 2y, and the integral of this would be minus ln y. And so we're almost there. So we say f parentheses x comma y is equal to, we take the unique terms from each component. So x times e raised to 2y, we write it down. Then we take the unique items from here. Since we already have x times e raised to 2y, we don't include this. And this is unique, so we go minus ln absolute value of y is equal to c. And that's all we need to do for this problem.